بسم اللہ الرحمن الرحیم. آج ہم نیکسٹ ٹاپک شروع کر رہے ہیں اور دیٹ از اباؤٹ precision and accuracy. These are the two terms which are used in measurements. So first of all, we define these quantities. Precision refers to the closeness of the measured value to each other. Closeness of the measured values to each other determines or refers as the precisions, and accuracy refers to the closeness of measured value to actual or standard value. Now we explain the difference between these two terms, precision and accuracy, with two examples. And the first one is dot game with the bull eye. Dot game with the bull eye can be explained as follows. Dot game with the bull eye there are 4 diagrams and we try to differentiate these two terms. These circles represents the bull eye, and first of all we draw the dots within the eye. In this case, the dots are very close to each other and also lies within the bull eye, that is very close to the bull eye and very close to each other. So this diagram represents that this result is precise as well as accurate. Precise, that these are very close to each other, and accurate because these are within the bull eye, so very close to each other and close to the bull eye. So the measurements is very precise as well as very accurate. The second one is that the dots are very close to each other, so the measurement is precise but far from the bull eye, and that's why precise but not accurate. The third one is in this case the dots are far from each other, so not precise but fairly accurate. Average is close to the eye, on that behalf we call it fairly accurate. And the other and the last one diagram, all the dots are very far away from each other, are not close to each other and not close to the eye, so we can say that result is neither accurate nor precise. Neither accurate nor precise. So that is the idea about these two terms. Here again, I repeat it that all the dots are very close to each other and very close to the eye within the central part. So the result is precise and accurate. Both terms are used, precise and accurate. In the second diagrams, dots are very close to each other but far from the eye, and that's why we declare the result is precise but not accurate. In the third diagrams, the dots are far apart from each other, so result is not precise but average is accurate. So we declare that not precise but fairly accurate. Not 100% but mean values is approximately equal to the fair result, and that's why we call it fairly accurate. And the last diagram, dots are far apart from each other as well as from the eye, so the result is neither accurate nor precise. So this is one of the examples to explain the concept of precision and accuracy. Another mathematical example we discuss. Let us consider a person weighs exact. Let us consider a person having weight 160 pounds. This is actual weight. But he measures his weight 3 times on 3 different scales. But he measures his weight three times on 3 scales, and the given data is as follows. Scale A gives the reading 170.1, 169.9 and 170.0 pounds. These readings made by that persons using scale A are close to each other but very different from this actual value. So we can say that the scale A, measurement of the scale A is precise but not accurate, mean not equal to, not comparable to the actual value. So result more precise but not accurate. Scale B 161, 162 and 158 pounds. The values are close to 160. Average of these 3 values is approximately equal to 160. So result fairly accurate but not precise. And the third reading of third scale, scale C, 159.9, 160 and 160.1. The third reading, the mean is 160, which is very 100% equal to the actual values, and readings are also close to each other. So result is very accurate and precise. So these three different measurements of a man explain the terms difference between the precision and accuracy. Another example can be discussed using another set of readings. Here is three students are trying to measure the value of acceleration due to gravity, and the first student measures the value of G by an amount 9.80, 9.79, 9.81, 9.80 and 9.80. Actual value of G is 9.8, and the measurements made by student number 1 are very close to each other and very close to the standard value of G which we take. So this measurement made by the student number 1 जो है, that is precise measurement is precise and accurate. Another student, second one, gives the reading as 9.71, 9.70, 9.69, 9.70 and again 9.70. Value of G measured by the second student, the values are very close to each other, but there is a difference in the actual value and these observations made by the second students. So the result is measurement is precise but not accurate. Third student tries, third one gives the reading 9.78, 9.84, 9.80, 9.76 and 9.82. The readings are not close, but their average is very close to the standard value of the value of G. So mean value, we add it and divide by 5, we get approximately 9.8. So readings, the measurements is accurate but not precise. And the last reading of last student 4 gives the data 9.61, 9.82, 9.74, 9.3, 9.7.00. So we observe that the values are very different from each other and their mean value is 8.69. So the measurements are neither accurate nor precise. Mean value of this group is 9.8. That's why measurements are accurate, but there is a difference between each other, so not precise. Here is the mean value 9.70. So the reading is not precise, but not measurement is precise but not accurate, not equal to the 9.8. And the here is mean value of the first student 9.8 meter per second square. So precise and accurate. So this is the mathematical observations, mathematical readings by different students, and we have tried to explain the concept of precision and accuracy by some examples. Another physical quantity we discuss, and that is uncertainties. In measurements. Uncertainties in measurements. So first of all, we try to define the uncertainties. Uncertainty is the range of possible value. It is the range of possible values within which the true value of the measurement lie. A range of possible values within which the true value of the measurement lie gives the idea of the uncertainties. Or another definitions, quantitative measurement of error in the data. Note, all measurements have a degree of uncertainty. All measurements have a degree of uncertainties. Mean uncertainty is always there in the measurements made by any experimenter, because every measuring instrument has least count. Every measuring instrument has the least count. For example, meter rod. Least count of meter rod is 1 millimeters. Mean it is not capable to measure less than 1 millimeters. Mean measurements made by the meter rod have some uncertainties always. Similarly, vernier caliper has the least count 1/10 or 1/20, which is 0.1 millimeters. 1/20 is 0.05 millimeters. It means these vernier calipers cannot measure less than their least counts. So uncertainties are there in the measurements made by these vernier calipers. The third one, screw gauge, has the least count 1/100, that is 0.01 millimeters. Measurements less than 0.01 millimeters cannot be measured by the screw gauge, and so on. I can generalize this concept that every measuring instrument has the least count. Every measuring instrument. So every measurement made by any one instruments, there is error. So there is uncertainty in the measurements. Maybe small, maybe large. Smaller the value of least count, more accurate measurement will be there. Our uncertainty will be least. So we can explain that the least count is the measure of systematic error, and skill of the experimenter making the measurements is the measure of random error. So we note these uncertainties, and there are some possibilities in these uncertainties, and that is inappropriate techniques or formula used by the experimenter, instrument least count of the measuring instrument, or faulty instruments, that is what we call systematic error, and skill of the experimenter making the measurements, we call it random error.